Hello everyone, welcome back. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 1727 largest submatrix with rearrangements. You are given a binary matrix of size m by n and you are allowed to rearrange columns of matrix in any order. Return the area of the largest submatrix within the matrix where every element of the submatrix is 1 and after reordering the columns optimally. Okay, if you look at this first example, the first column has 0 1 1, second column has 0 1 0 and third column has 1 1 1. If we swap the column 1 with column 2, then you will get this particular arrangement, and if you see this particular submatrix has an area of 2 which is the largest area. Okay, if you observe, okay, we have to optimally switch the columns. Okay, if you look at this example, after looking at this example I got certain idea that if you see I have 1 1 1, okay, and they have brought all the ones to the right in some particular fashion. We don't know what particular fashion it is and how many swaps it required. It doesn't matter to us. Okay, all it is we want to accumulate all the ones to particular end. Either it is in the starting or it could be at the end. Okay, here they have accumulated all the ones to the start, and if you see the area of this matrix is basically 1 times the length, which is 3, correct? Okay, now it could be ones over here if you visualize it with 2's. Okay, so the area would become 2 times the length, which is 3, which is 2 times 3 is basically 6. Okay, so if somehow we can reduce this particular matrix into a single row and if we can sort the values, then we can get the answer. But how can we reduce this into a single row, and what should be the fashion in which we have to reduce? Okay, if you look at this example, this particular one and this particular one got accumulated, right? And that is the reason its breadth has become 2. Okay, and these two are basically as it is. Okay, in the end these two got accumulated into 2 and these two got accumulated into 2. Okay, we have to somehow get into this particular fashion. Okay, that means we have to do prefix sum of columns from downwards to upwards. Okay, so the prefix sum, if I come from down, the last row will remain as it is. Okay, and the last but one row will look something like this. Okay, 1 plus 1 is 2 and 0 plus 1 is 1 and 1 plus 1 is 2. Okay, and the topmost row will be, since it contains 0, will again set it back to the 0. Okay, and if you look at the second column also has a value of 0, so we'll again reset the value to 0. And the third column has 1, that means we have to accumulate from the previous rows, right? So then it will become 3. Okay, now if you stand alone look at this particular row, the maximum area of the matrix you can get from this particular row is 3. If you stand alone look at this particular row, okay, then how can we have to somehow rearrange this? Okay, so if we have to rearrange optimally, let's say I am sorting it in the ascending order. Okay, so this can be formed after sorting. The elements are just rearranged. Okay, we have a flexibility to rearrange columns how many times, right? Any number of times, right? So I will just sort it and I will calculate the area of matrix from each element till all the end. Okay, if I consider one area of a matrix with length 1, then it will be 1 times 3. If I calculate area from here till all the way till the end, which is 2 times length, because it is in the increasing fashion, so I can extend 1 in the rightward direction, I can extend 2 in the rightward direction, right? So 2 times 2 will be 4. That is the maximum area I can get. Okay, I hope you got the understanding why we are taking the prefix sums and why we are sorting it. Okay, sorting helps us to arrange the elements in the increasing fashion, and I can easily extend a particular element to its right, okay, because all the elements are higher, so I can definitely for sure get a matrix of size which is less than or equal to this particular element, okay. Yeah, I'll just show you the implementation. It is pretty easy. I have taken m and n as the length and breadth of the matrix, okay, and as I mentioned, I have to compute the prefix sums from downward to upward direction, right? So I'm leaving the last row because the last row will remain as it is, and I will start from m minus 2 row and go all the way up to the 0. We'll start at m minus 2 and go all the way up to the 0, and I will have to compute for each and every column, right? If the value at the current position, if it is 1, then only I will accumulate the prefix sums, okay. So matrix of ij plus the value coming from the next row, okay. This will make sure this particular matrix has been transformed into this particular fashion, okay. Now that I have to go through each and every row and sort it. I'm starting from 0th row and going all the way to the end, and I'm sorting the each row, and then I just have to maximize my answer, and the value will be at each column the value would be matrix of ij times n minus j, okay. That is what I'm extending. The length breadth will be n minus I, okay. That is what the breadth will be. In the end, I will just return my answer. If you submit this, you will see that all the test cases will be passed and the solution is pretty efficient as well, okay. If you analyze the time complexity, we are computing the prefix sums for the entire matrix, right? We are iterating through each and every element, that is order of n square, and after calculating the prefix sums, we are sorting the each row, that will be n log n, and then we are just iterating, right? Yeah, um, that's all about this problem. If you like the explanation, hit the like button and hit the subscribe button, and also share your valuable feedback in the comment section. I will be posting solution in multiple languages such as Java, JavaScript, Python. If you are coming from any other languages, feel free to check out the solution in the description. I will be providing the link. I've also started a dynamic programming series. If you are interested to learn the dynamic programming, feel free to check out the playlist as well. Thank you.